Helping us out today will be Michael Sarate.
Hi, my name is Michael. I'm from Miss Anand's class, as some may know. Today we're going to be working from section 10.4, number 17. It's asking us to find the area of the region enclosed by one loop of the curve. The curve is 4 cos 3 theta. Now, if we graph it out, this is what it will come out to. The red portion would be the entire graph. And we're just trying to find one loop. But in order to get this graph, we had to come back to the original cos and we graphed it out. This is how it would look like from 0 to 2 pi. So it would just be from 0 to pi over 6, and it would go to pi over 6, 0, and it will go to pi over 3, but at pi over 3 it would be negative 4, because it's coming down this way, and it's going back to 0 at pi over 2, and it's going to go to 2 pi over 3, and it's going to be a positive 4, and it's going to come back down to 0 at 5 pi over 6, and then it's just going to repeat itself. It's going to go at pi, it's going to be negative 4, so it's going to be pi, negative 4, so it's going to come over here. It's going to come down this way. And then from there on, it will just repeat the exact same way that I just showed you. So, from this, we just need to find one loop, which we'll just do this loop. And these angles are 7 pi over 6 and pi over 6. But if we say from pi over 6 to 7 pi over 6, it'll be this entire graph. But we just want this portion, so we have to change this angle. And in order to do that, we subtract by 2 pi. And that would make it negative pi over 6. So, our limits would be from negative pi over 6 to pi over 6. But in order to find the area of the region, we're going to apply the formula of the area of the polarity equation, which is 1/2 r squared d theta. A equals, as you can see, it's negative. Let's just pretend, change it to variables. It's going to be negative a to a. So we can change that. We can cut this in half. So we multiply the equation by 2, and we go from 0 to pi over 6. 1/2. We're going to apply r. We're going to plug it in. Be 4 cos 3 theta squared d theta. So if we pull out this 1/2 and multiply it to the 2, so it's going to be 2 times divided by 2, which is just 1. So it's going to be pi over 6, 0, and then 4 squared is 16, and it's going to be cos squared 3 theta, d theta. So we can pull out the 16. And for this equation, we're going to apply the half-angle theorem, which originally is 2 cos squared theta minus 1 equal to cos 2 theta. So 2 cos squared theta equals to cos 2 theta divided by 2 divided by 2, plus 1. Divide that entire thing by 2. It's going to be cos squared theta equals to cos 2 theta plus 1 all over 2. But as you can see from here, this is different than this. So we're going to have to plug in 3 theta for theta. So let's bring this up here. So it's going to be cos squared 3 theta equal to cos 2 times 3 theta plus 1 divided by 2. So cos squared 3 theta equals to cos 6 theta plus 1 all over 2. So this equation we are going to plug in to cos squared 3 theta. So now it's going to be area equals 16 from 0 to pi over 6 cos 6 theta plus 1 divided by 2 d theta. Area equals, we can pull out the 2, we can bring it out. So it's going to be 16 over 2. And then go from pi over 6, 0, cos 6 theta plus 1 d theta equals, we're going to integrate this. So it's going to be 8 because of here times the cos of 6 theta would be sine 6 theta all over 6. And the cos of 1 would be theta. From 0 to pi over 6. Now we are going to apply the limits. It's going to be 8 times, we're going to plug in pi over 6 into the equation. Sine 6 times pi over 6 divided by 6 plus pi over 6 minus sine 6 times 0 divided by 6 plus 0. I'm going to move on up here. Area equals 8. And sine of 6, well, 6 times pi over 6 is just pi. So sine of pi is 0. So it's going to be 0 divided by 6 plus pi over 6 minus, and then 6 times 0 is 0. So sine of 0 is 0 over 6 plus 0 equals 8 times, so it's going to be 0 and 0 plus 0 plus pi over 6. This is going to be pi over 6. A equals 8 pi over 6, and then we can reduce that to 4 pi over 3. And this will be your final area of one loop. And that is your final answer for one loop.